Good evening to all. Today we start our fifth day, ninth session of online Atal FTP, organized by Department of Computer Science, Majlis Arts and Science College, Autonomous. I invite Dr. Geeta Nambiar, Professor, Department Chemical Science, Majlis Arts and Science College, to deliver the welcome address. Ma'am, please.
Thank you, Chitira. Am I audible?
Yes, ma'am.
Okay. Good afternoon to everyone gathered here. It is my pleasure to warmly welcome you all to today's technical session titled Understanding and Mitigating Bias in AI Models, a Technical and Ethical Perspective. In an era where artificial intelligence is rapidly shaping decisions, systems, and societies, accountability and transparency have become more important than ever. Today's session aims to shed light on these crucial dimensions and help us to understand how to build AI systems that are not only intelligent but also responsible and inclusive. We are honored to have with us Dr. Sheena, Assistant Professor, Department of Computer Science and Engineering, College of Engineering and Management, Punyapra, who will be leading this highly relevant and insightful technical session. Her main areas of interest are artificial engineering and machine learning. She has done her PhD in the topic Design of Energy Efficient IoT Internet of Things Network Protocols with Improved Security, Privacy, and Lifetime. Her expertise and experience in this field will undoubtedly enrich our understanding of both the technical mechanisms behind AI bias and the ethical approaches needed to mitigate it. I would also like to acknowledge the presence and support of our rapporteur, Ms. Aishat Sufaina, who will be capturing the key discussions and takeaways from today's session. A special appreciation goes to Sri Akhil, who is managing the technical support for the event, ensuring the seamless flow of program. And finally, I extend our thanks in advance to Ms. Jinsi PB, who will be delivering the vote of thanks towards the end of this session. And once again, I welcome all the participants to today's session, and I request Dr. Sheena to handle this session. Ma'am, please.
Thank you, ma'am. Am I audible?
Yes.
Am I audible?
Yes,
okay,
yes.
Okay, thank you. Okay, thank you, ma'am. Okay, thank you, ma'am. So,
yes.
Thank you for giving this opportunity for delivering a talk on this AICTE Atal FTP organized by Computer Science Department at Majlis College of Arts and Science, Autonomous. So, I'm sharing my PPT. 1 second. Is it visible?
Yes.
Okay, thank you. Okay. Today our topic is understanding and mitigating bias in AI models, a technical and ethical perspective. Hope that in the last sessions you will get a good idea about what is AI, what is data science, and what is machine learning. Then the artificial intelligence is the superset, and under this we have the machine learning, deep learning, and also the data science. So you have, I hope that you all have a very good idea about the interconnectivity of these terms and how it is related to each other. Then the artificial intelligence, the main component of this artificial intelligence is the machine learning algorithms. That means the machine learning algorithms are the engines and data is the fuel of this program. That means when you given data set to this machine learning algorithm, then only you can build a model. So that is why it is machine learning algorithms are called the engine of this process, and the data is the fuel of this process. Then this AI has various applications in many areas, in wide variety of areas, like robotics, robotics, Internet of Things, image analytics, graph analytics, visual personal assistant, computer vision, simulation modeling, machine translation, etc. So in almost all area, we can see this AI. Nowadays, everything is with AI. Nothing can we do with without this AI. That we now is in that stage. So when you search in Google, so something it is related to AI. That means nowadays the Google search team AI is exponentially increasing. 2005 it is almost up to 10. Then now it is in 2025 the exponential increase of this search term AI in Google. So this exponential growth of this search term because of this wide use of this AI models and machine learning in various applications. So here we can see the hype cycle for the artificial intelligence also. Okay, artificial intelligence also is very much increasing and it has reached the responsible AI, now explainable AI, like that. So when we now see the global risk in 2025, so the extreme weather is the top. When you can see the top 5 global risk in 2024 in this graph. So here you can see the extreme weather, it has 66%. Now second most is the AI generators misinformation and disinformation. It goes to 53%. Okay, that means AI also has some risk. That means the usage of AI, the usage of this AI trends to some global risk also. So we all know the decision making. Decision making is the main factor. So here we can see the unseen mirror. That means for a crucial decision, the human decisions are very much important. This human decisions are replaced by this AI. So AI, because of this efficiency, scaling, and objective progress, that means it can do any job. Okay, so when we designed artificial intelligence, our goal was to replace the imperfect and subjective human judgment with objective, scalable, and highly efficient automation. So, but we saw AI as a way to escape our own flaws. That means this AI, we now realize that AI is not neutral. It is an objective entity. That means it is a mirror that the bias in AI reflect the mathematical and computational error of this human also. That means human errors can enters into this AI. That means it reflects the data, the assumptions, and the historical inequalities of the world we fed into this AI. So every decision maker, human or machine, operates some systematic error. So we have to remove this human error embedded into this AI. So AI automates decisions at a scale, but how we can ensure it automate fairness, not discrimination. Okay, that means we have to build AI system in a systematic way or in such a way that it should be fair, fairness, and it cannot implement any discrimination between the people or the society. So what do you mean by a bias? bias in AI. Bias in AI means the bias in AI results in unfair or discriminatory outcomes due to flawed data or models. That means we build a data or models, so we have some flawed data or some design views. Because of that, there comes some errors. That is called the AI bias. So to understand how bias creep into AI system, so first of all, we need to grasp how AI makes its decisions. So AI is powered by advanced algorithms and machine learning models, which mimic the human brain. Okay, that is the learning behavior. So this AI inputting massive data set into those algorithms. So that enables technology to make inferences, draw conclusions, and predict future trends. So sometimes the data sets are skewed or incomplete that reflects some errors into the output of the AI. When those data sets are skewed or incomplete, so the assumptions or the predictions may be different. So sometimes it reflects faulty inferences or inaccurate predictions, and even very stereotypes errors like that. That means it may concentrate on some community like that. So there is a social discrimination. So what are the impacts of this AI bias? So societal inequalities, as I said earlier. Suppose some data is fed into this AI system. While building the AI system, some discrimination is there that arises societal inequalities. So reinforcement of stereotypes. So sometimes some words may be used for misunderstanding. That means he or she may be used for some common common name like doctor, like that. That will come later. Then ethical and legal concerns, then economic impacts, then business impacts, health and safety impacts, psychological and social well-being. So these are the impacts of AI bias. So we should address this AI bias. So the biased model amplify existing societal harm at a systematic and scalable across critical applications. So we have to implement or develop a AI system that should be not harm to any society. Okay. So here are some real stories. So Amazon hiring problem. Amazon hiring problem. Sometimes you may heard about that. Amazon hiring problem means AI automation. It is an AI automation product that helps recruiters so that they can do the recruitment very fast. So they collect the resumes, and based on the resumes, the recruitment process is done. So when working correctly, the software should help recruiters and candidates with the right skill set to meet the necessary job requirement. But the algorithms are trained based on the data set that fail to exclude gender from their considerations, then the software may wrongly gender into account as it sifts through applicants. So the result of this is that it excluded from positions that are typically dominated by one gender or another. So that is the Amazon hiring problem. And another problem is COMPAS. COMPAS means correctional offender management profiling for alternative sanctions. That means that this is an algorithm that means it is used by legal systems nationwide to predict the likelihood of recidivism for the likelihood of a repeated offense. So it outputs predicted the reduced occurrences for black offenders more than once as often that of a white offenders. That is the compass problem. Then next one is in the financial sector. In the financial sector, it is for the loan eligibility. So some AI tools are used to determine the loan eligibility in the financial sector, have discriminated against minorities by rejecting loan and credit card applications. They have done by taking irrelevant parameters into their calculations, such as applicants' race or neighborhoods where they live, like that. So that is in the financial sector. Then another one is the face recognition bias. So MIT lab developed a system MIT lab studied revealed higher error rates for the darker skinned individuals. So that means darker skinned individuals have higher error rate. That means there is a discrimination problem. Then next one is Google Photos incident. So it is another problem that occurred. So that means it is a misclassification of the black individuals as gorillas. Okay, so these are some real stories of AI bias. So our aim is to that means bias in AI is not merely a technical issue but a societal challenge. So where does bias occur? So bias may occur, that is, the AI and AI pipeline. While developing an AI model, we have a pipeline. In the case of an ML also, we have a pipeline. So the bias occur in the stages of AI pipeline. So first step is the data collection process. In the data collection process, bias often originates from here. If we used data, if the data used to train an AI algorithm is not diverse or representative, the resulting output will reflect these biases. Okay, for example, training an AI on historical hiring data from a company that favored only the male applicants. That may lead to bias hiring recommendation. That I said earlier, Amazon's hiring problem. So in that case, suppose it is the data is mainly for the male applicants. That means hiring data from male applicants. That means the feature that used is only for the males. Then that classification may be mainly for the male applicants. So the data collection is a major part where AI bias occurs. So the bias risk is unrepresentative samples, lack of diversity, historical inequalities, etc. So next one is the data labeling. Data labeling means the process of labeling the training data can introduce bias, as human annotators may have different interpretations of the same data. Okay, data labeling is a process labeling the data. So the annotators are the human itself, so they may have false interpretations. Due to that, bias may occur. So in the case of sentiment analysis, categories or facial expressions can be influenced by crucial or personal biases. So next one is the model training. Model training, after the data collection and data labeling, the next step in the AI is the model training. So in the case of model training, we have used different types of algorithms, optimization technique, and many architectures are used. So the training data is imbalanced, or the model architecture is not designed to account for the diverse input, the model may produce biased output. So algorithmic biases can also arise from the optimization technique that favor majority group of predictions over minority groups. So in the case of the model training, we have to design a perfect algorithm that include all the inputs that contain different all the historical data surveys and also categorized inputs, and develop an algorithm and also optimization techniques can be arise biases. So the bias risk is imbalanced training data, then algorithmic fairness issues and majority group favoring. So algorithm maybe not as much include all the details. So next one is the deployment. After model training, the next stage is the deployment. Deployment means even if the model appears unbiased during training, biases can still emerge even deployed in real world applications. So if the system is not tested with a diverse input, deployment means we have to deploy the system for particular application. So in the deployment, we tested with diverse inputs or monitored for bias after deployment. So in that case, lead to unintended discrimination or exclusion. Okay, so these are the stages where the bias can occur, and it is a continuous feedback after deployment. Then evaluation and updates can be done. Again, the data collection process is continued, labeling. So it is a continuous feedback loop. That means after deployment, again the system they have some errors. Then again, some other data is collected. So in that data also may contain biases. So it is continuous feedback loop for evaluations are updated based on the real world interactions and the new data for this continuous feedback loop. So next is what are the different types of AI bias? There are different types of AI bias. The biases are the sampling bias, algorithmic bias, and the measurement bias. In addition to that, some other biases also there. That confirmation bias, generative bias, reporting bias, automation bias, then outgroup homogeneity bias, then stereotyping bias, etc. So first one is the sampling bias, that is also called the representative bias. So sampling bias means in which data are skewed in a way that is driven by some methods of capturing or selecting the data. Okay, the training data that does not reflect the diversity or the distribution. That means that does not include the whole population itself, which lead to bad performance and biased and unfair decisions. So this bias can cause due to incomplete or poor collection of data process and poor selection criteria. So the consequences are the poor performance, biased decisions, and unfair outcomes for underrepresented groups. So here one example for this sampling bias. So in sampling bias, here it is 0.8% of light-skinned men and 34.7% of dark-skinned women. That means here the system is trained with a majority of white-skinned people, then it does not perform well on the dark-skinned people and other races. Okay, so the sampling data does not reflect the diversity or the distribution. So the mitigation is the collect representative data set that include all the demographic segments. That means we have to collect all the enough details for the light-skinned men and the dark-skinned women, so that the model can ensure the correct output. Then next one is the algorithmic bias. The algorithmic bias means so we have designed an algorithm or overall mechanics of a model that bring assumptions and pattern from their worldview into its design. That means systematic error due to the design, implementation, or optimization objectives of the learning algorithm. That means we design the system after designing, then write an algorithm for that process, then implement the system. So error comes in this algorithmic process. So the algorithmic bias occurs due to the fault in the design and implementation of the algorithm. So in this type of bias, the system prioritizes certain attributes which lead to unfair decisions. So many factors for writing the algorithm, so many attributes are used. So some attributes may have the major priority. So this can be caused by limited input data or poor algorithm design, and this bias can be repetitive, and it is a systematic. So the root cause is the design assumptions and the optimization objectives, and the consequences are prioritization of the specific input attribute that leading to repeated non-random disparities. So one example here is the hiring problem. In the hiring problem, we already saw that it is mainly for the male, it is majority for the male applicants. That means this type of bias was seen in hiring decisions where the algorithm was seen favoring the males over the females because the algorithm received constant input from the resumes of the males. So this signifies the lack of diversity in the training data set. So the data bias is the most important factor that affects the algorithmic bias. So the mitigation is focused on in-processing technique, integrating fairness constraints. Next one is the measurement bias. Measurement bias means it happens when the data collected systematically differs from the true variables of the interest. That means if a model predicts, suppose for example, if a model predicts student success based on those who completed the online course, here is the example, but failed to account those who dropped out, leading to misleading conclusions. That means that that model only track the students who have completed the online course. Sometimes the students may drop the course, so the model cannot fail to find out the dropped out students. So that leading to misleading conclusions. So the measurement bias is typically used to describe faulty sensors and measurement devices, but the measurement isn't always the objective. So in many cases, measurements can depend on the views and judgments of individuals recording data. So the measurement bias occurs when the data collected measures certain groups and underrepresents them. So the consequences means misleading conclusions and flawed model predictions. So the mitigation requires rigorous validation of data collection methods and instruments, careful definition of the input variables, and avoiding proxies. So we have to mitigate this measurement bias using the validation of the data collection process. So this can be often confused with a representative bias, as they very similar as they occur due to inaccurate representation of the population. But here the measurement bias actually measuring the data, that is measurement of the data is incorrectly with the actual data. Next one is the generative bias. Generative bias means the type of bias that occur in the generative AI model. So here the text or images that exhibits unbalanced representations or unwarranted uniformity in context. So the generative AI model creates new data such as images and text based on a various inputs they receive. So this type of bias occurs when the model output has unbalanced representations in the content. You know, the generative AI, the case of generative AI, when we give some image input and give some prompt, it will generate new images. So actually, when this images unbalanced representation, that means that model is developed not correctly, then it may generate faulty results. So the main cause of this bias is training data overrepresents specific demographics, cultures, or concepts. That means that system is developed using the particular demographic or particular culture or based on particular concepts. So based on that only it generate the output. So here one example. Here one example, it shows the model is trained using certain ethnic cultural literature, suppose Western culture, but which may cause underrepresentation of other cultural literature. That means the output is not actually correct with the trained model. Okay, it is trained with the Western culture, but the output is generated with other culture. So that is the bias in this generative AI model. So the mitigation is careful curation of the training corpus for cultural and demographic diversity, along with the prompt engineering and safety filters during the deployment. So sometimes when you give an input, give an image and give some prompt, it will generate totally different images. That is the main issue of this Gen AI. So that is the generative bias. So to mitigate that problem, the Gen AI model should be built in such a way that the training corpus should be correct. That means it should include all the cultural or the demographic diversity, then only it will generate the actual or the correct output. Next one is the reporting bias. Reporting bias means there's a mismatch between the frequency of events in the data set and the true real world frequency. So, for example, in the sentiment analysis case, where the training data set may not be accurately reflect the distributions of the sentiments. So in this example here, the training data, it is more exclusive positive, negative, and also neutral, and positive, and also neutral. Sometimes the neutral in this area also, but here after developing the model, the result should be totally different. Okay, that means the distribution is totally indifferent. So that is the reporting bias. There is a mismatch between the events. So that the main root cause of this reporting bias is events that are more visible, dramatic, and easily reported overrepresented in the collected data, while common or mundane events are not underrepresented. So that means the consequence is the inaccurate understanding of the possibility. That means here it is the model does not correctly recognize the output. So understanding of possibilities and distributions in a target domain. Inaccurate understanding and probabilities and distributions in the target domain. So the target domain is totally different from what we have given in the test domain. Okay, so to mitigate that problem, it requires active strategies to capture data reflective of all the outcomes, including those with the less frequently documented. That means less frequently documented and all the data should be all the data should be given to the system correctly. The use of the weighted sampling or the recalibration of technique to correct the skewed frequencies. That means frequency of the data should be correct, should be in correct format, then only it will generate the correct output. So next one is the automation bias. Automation bias occurs when the automated system, the human operators favor or truly rely on only on the inherently more efficient, accurate, or objective than the human performance. So the humans are depend only on these automated systems. Then consequences, sometimes this automated system generate faulty outputs. So the output faulty output, and it may generate some consequences. Okay, so in the case of here one example. So in some hospitals, it depends upon only the automated system. Sometimes that system may generate the faulty result, but the doctor or the nurse, he rely only on this automated data, then it may generate problems. So the consequences potentially results in a biased or unfair decisions. So especially when the automated system has higher error rate than the human expert. So depending on this data, the doctor decide whether what should he suggest to the patient. So the data is not data is incorrect, then the faulty decisions may be taken by this doctor. Okay, so the mitigation is training program emphasize critical evaluation of AI outputs, mandatory human in loop the verification protocol. That means include human in the loop of verification protocols. That means for the verification side, we include human interaction. So it will generate the correct AI model and displaying confidence scores and uncertainty metrics with the automated systems. Next is the stereo bias. Stereotyping bias means it is mainly concentrate on some specific social or demographic group. For example, in the case of a doctor or nurse, doctor mainly it is gender specific pronouns like he, and for nurse gender specific pronoun like she. So that type of bias is called stereotype bias. Actually, they are the neutral, not gender specific. So in the case of the image generation model, predominantly portraying engineers as male and caregivers as female. So that type of bias is called the stereotype bias. The mitigation is requires careful debiasing of the word embeddings when you represent in the representational space. The next one is the group attribution bias. Group attribution bias means generalizing the group characteristics and belief or behavior to every human or member of that group. So group membership is a proxy for the individual traits. So that means individual is treated as based on the output of the group activity. So leading to unfair individual assessment and the discriminatory outcomes. So one key concept related to this is in-group bias and the out-group bias. In-group bias means higher score towards the individual belong to the specific group. And out-group means minority or the external group as being more likely than the truly there. So mitigation is training models to rely on individual domain relevant features rather than demographic proxies, and designing data collection to capture sufficient within the group variation. So these are the different types of bias. So in this bias, mainly the main biases are the sampling, algorithmic, and measurement bias. So next, what are the bias mitigation techniques? So mitigation techniques also rely on the AI pipeline. You know the AI pipeline, data acquisition and pre-processing is the first one. Then training and the prediction and evaluation is the in-processing stage, and the prediction and evaluation is the post-processing stage. So in the data acquisition, data augmentation, that means diverse training data is key to reducing the bias. To use the diverse training data. Data augmentation involves deliberately introducing a variety of perspectives and background into the training data set. Okay, we have already seen that data set contains irrelevant data, and also sometimes may lack of the some types of like the gender or some community. So it may lead to some gender specific problems or some society problems. So it can be by introducing variety of perspectives and background to the training data set. So this helps the AI model learn to generate contents that is fairer and more representative. That is data augmentation, and also resampling techniques. Resampling techniques means another approach employed in that involves resampling the training data to ensure that underrepresented groups get more attention. That means sometimes some groups may be underrepresented. So give more attention to that one, and this helps in balancing the model's understanding of different demographics. That is the data acquisition and processing stage. Then adversarial training in the model training. Adversarial training means adversarial training is like a game between two neural networks. one network generates the content and while the other evaluates the bias. Okay, so the process helps to generate a model that becomes skilled and avoiding the biased output. So actually there are two networks. One is one generate the content and the other is evaluate the bias. So adversarial training involves training two neural networks, one to generate the content and other to evaluate the data. So it is like a cat and mouse game to avoid the biased outputs. The next one is the prediction and evaluation, that is the pre-processing state. So in the prediction and evaluation state, we can use explainability tools and bias metrics. That is, explainability tools helps to understand AI model decisions, while bias metrics quantify the bias in AI generated content more accurately. So explainability tools and this metrics are crucial for identifying and rectifying the biased decisions. So that's the model explainability tools and bias metrics in the prediction and evaluation stage. So here you can see the different biases, behavioral biases, presentation biases, then data. In data, we have the historical bias, aggregation bias. Then after the data bias, it goes to the algorithmic bias. It is a statistical and computational bias. Then popularity bias that will generate some other biases and user interaction, and it is a feedback loop. Then strategies to mitigate the AI bias. So there are different strategies to mitigate the AI bias, like data curation, model fine tuning, inclusive data collection, algorithmic fairness techniques, continuous monitoring and auditing, diverse deployment teams, then governance and transparency policies, human oversight, etc. So this data curation means, as we said earlier, the data involved. That means companies needed to highly responsible for the type of the data that they input into the models. So ensuring that the training data used for the system is curated from a diverse range of data sources. Okay, that is data collection, inclusive data collection. Then algorithmic fairness, as we said earlier, the algorithmic, the design flows, it should eliminate the design flows in the system. Then continuous monitoring and auditing means after the algorithmic design, we deploy the system, then continuous monitoring and human involved protocols are used to evaluate and validate the systems. Then again, that flows are given to flows, depending on the flows, again, data is collected. That process is a feedback loop. Then diverse deployment teams, then different teams for deploying the system. Then governance and transparency policies, the policies that is used to develop that AI systems. Then human oversight, that is human in the loop. Who developing that system, human is in the loop, so the humans can validate the system. So this bias may occur in the LLMs. LLMs means large language models, where this large language models are used. So to mitigate the bias in large language models, the different strategies are used. That is the data curation, model fine tuning, multiple methods and metrics for evaluation, logic in addressing LLM bias. So the data curation, as already we have discussed, that data curation means diverse range of curated data from the diverse range of data sources. So the text data set that have come from different demographic languages and cultures that will balance the representation of the human language. So this ensures that the training data does not contain unrepresentative samples and guides targeted model, etc. So model fine tuning means after developing the model, we can fine tune it. So in the case of large language model, first we develop a model in such a way that that contain very large data set So we build the system that can do multiple tasks. That is called the pre-trained models. So the pre-trained model, it is an knowledge. That model can be used for developing the another system. The traditional machine learning, we develop a particular system for a specific task. The model is developed for a specific task, and a specific data set is used for that. But in the case of LLMs, actually we develop a model that is a generalized model, and we can use that model for developing another task. So that model is actually act as a knowledge. Okay, so in that type of learning is called a transfer learning. We can that means the transfer learning to another specific task. So that process involves using a pre-trained model and training further on its based on a smaller or more specific data set. That means the pre-trained model is developed using the big data set, very large data set, and for a specific task we can develop a model without the training or without training. We can use the pre-trained model as such to develop the second task. For example, simply we can say that we have a large data set of ImageNet. Then that ImageNet can recognize or identify the various images. Suppose I want to develop a system for identify a particular image only. For example, it is a cat or not. So I can use that pre-trained model. So my dataset is given to that pre-trained model, and embeddings are generated. Based on the embeddings, I can use any classification method to classify my dataset as a dataset contains the samples contains cat or no. That is the model. Pre-trained models. From the pre-trained models, we can generate fine-tuning models. Fine-tuning means some of the parameters of the pre-trained models are changed. That are the hyperparameters. Then we can develop new systems. Okay. So bias reduction techniques means organization that should go for extra mile or implement a bias detection tool into their process. That means here, when you develop the system, the data set is very small. That may bias may occur in the continue to the variety of the data and variety of data. Then multiple methods and metrics for evaluation. That means in order to continuously grow AI systems that can safely integrate with different multiple methods and metrics used in their evaluation process. So different evaluation methods are used to validate the systems. Then logic in addressing the LLM bias. So the importance of logic and structured thinking in LLM allows the models to be able to process and generate output with application of logical reasoning and critical thinking, so that LLMs can provide more accurate responses using reasoning behind the system. So the process consists of building natural language model in which the relationship between the tokens are considered neutral, as there is no logic stating that there is a relationship between the two. So the system is trained this method on a language model and found the newly trained model as less biased without the need for more data and the additional algorithm training. So this logic-aware language models will have the ability to avoid producing harmful stereotypes. So that is the LLM bias mitigation methods and mitigating image-based bias. So here also we can use the diverse training data, then data augmentation and fine-tuning. Okay, so these terms are we have already discussed. So here also in the image-based bias means that the images are used for building the system. So here, broader representation of the demographic, culture, and the text, that is diverse training data. Data augmentation process are also there that enrich the data input. Then for the training refinement, we fine tuning the system. Then after mitigating the bias, we have a responsible AI. Responsible AI means that AI encompasses large set of practices, considerations, and AI-driven software development methodologies that ensure the ethical and accountable, trustworthy implementation of AI. That means responsible AI has some ethical considerations. Based on that ethical considerations, it developed the AI systems. So that system should be trustworthy. So that responsible AI, so the responsible AI principles are the anti-bias, transparency, and explainability, privacy and protection, accountability, societal impact, collaboration and multi-stakeholder engagement, robustness and safety, human-centric design. So the main factor of this responsible AI are accountability, transparency, data and privacy methods. So transparency means the transparency in AI involves clear and open communication about the AI's workings, data usage, and decision-making process. That means the system should be transparent in all fields. That means the data usage and decision-making and working. So the key points are the explainability, that provide understandable explanations of how AI models make decisions. That means when you build an AI model, it should be each stage of the system should be explainable. Then documentation, all records of the data sources, model design, and testing procedure should be documented. That means everything should be documented in such a way that when a third person can easily understand what all process has to be done for developing that system. Open access means sharing information about algorithms and dataset with stakeholders and public. That means it is open to all. Anyone can use that system, and the design, the algorithms and dataset also open. So anyone can modify it or use that system for their work. The benefit is trust enhances user trust and confidence in AI systems. So the improved outcome is it facilitates better understanding and correction of potential issues or biases. That means that facilitate understanding and correction of potential issues or biases means that arises some potential issues. So accountability means everything should be accountable. That means accountability involves ensuring AI systems and their impacts are monitored and developers are responsible for their actions and outcomes. That every stage of that system are monitored and that developers are responsible for their actions and outcomes. The key points are responsibility. That means clear identification is who is responsible for AI system performance and decisions. That system should be performed. The performance of the system should be in such a should be in high level, and clear identification of who is responsible for AI system's performance. That system should be developed in such a way that it performed well. So for this, a regular audit to assess AI systems for compliance with ethical standards and regulation. That means every stage of the system that should be auditable. So feedback mechanisms, channel for users and stakeholders to report issues and concerns with the AI systems. That means when the system, that system is open to all, so that the stakeholders and users can report errors about the AI system. So it can be corrected by the developers. So the benefits are mitigation of risk, help address and rectify issues promptly. That means that is when the stakeholders report the errors promptly, so that the errors can be rectified very easily. So regulatory compliance ensures adherence to legal and ethical standards. That means the system is developed in such a way that adherence to the legal and ethical standards. So the transparency and accountability, there are some real incidents. Suppose you may know about that, the Facebook Cambridge Analytica scandal. So the incident is the misuse of the user data by the Cambridge Analytica for political proofing and targeting. That means Facebook data is used by the Cambridge Analytica for the political profiling and targeting. I think it is in many large user profiles are misused by this Cambridge Analytica. So the issue is the lack of transparency in data handling and the user consent. So without the consent of the user, this user profiles are used for psychological profiling. So the outcome is increased calls for stricter data privacy and regulations and greater transparency in the data practices. Because of this scandal, privacy regulations are changed. So stricter data privacy and regulations are used for developing the system. Next is IBM Watson for oncology. So in that IBM Watson for oncology, it is a tool for testing whether there is any malignancy. So that is used mainly for the cancer treatments to find out whether flawed or whether there is any malignancy in that person. So that is flawed or inconsistent because of this transparency in the AI decision making process and accountability for its clinical applications. Okay, that means the data is transparent. So some data may be flawed or that is used for some other applications. So the outcome is raised concern about the need for thorough validation and transparent communication regarding the AI system limitations. That means that system contains some flawed and inconsistency, so that the system cannot predict correctly whether there exists any malignancy or not. So they recommended thorough validation and transparent communication regarding the AI system limitations. The next one is the explainability. Explainability means that refers to the ability to understand and interpret how AI models make decisions, providing insight into the model's logic, predictions, and output. That means the system should be explainable in such a way that it can interpret how this model is developed and how this model is take decisions about that system. Then by using that logic, how these predictions are arrived. So the key points are the model interpretability. That means ensuring that AI models are interpretable by the humans, allowing stakeholders to understand how decisions are made. So that models are interpreted by the human beings. So all the stakeholders can understand how these decisions are made. So transparency in the decision making, provide clear and accessible explanation for the outcomes produced by the AI systems. So all the outcomes of this system should be clear explanation about what is given to that system. So explainability enhances users' trust, leading to wider acceptance and appropriate usage of the AI technologies. So the benefits of this system is improved debugging and validation. That means easier identification and correction of errors in the model. Debugging means correction of errors. So the system is errorless and more validation techniques are used. Then ethical compliance ensures decisions align with the ethical standards and values. Some ethical and some policy standards are there. So it ensures align with the ethical standards and policies. Hello. Yes. Yes. Any doubt? May I continue? May I continue?
Yes, ma'am.
Okay, thank you. Then regulatory adherence means the meeting legal requirements for the transparency in the decision-making process. So this explainability, there have some real-life incidents highlighting this explainability. That is Apple card garden bias in 2019. That issue is the women received lower credit limits than men with the similar profiles. That is a credit card issue. So in that, women received lower credit limits than the men with the similar profiles. Then explainability means lack of transparency in the credit limit decision led to accusations of the bias. Second one is AlphaGo's decision making. We all know what is AlphaGo algorithms. AlphaGo algorithms use it as a gaming algorithm in a system, first algorithm in the AI system. So the issue with this AlphaGo algorithm is it is the black box nature made it hard to understand its strategies. So it is very difficult to understand the AlphaGo's black box nature that is not explainable. That is highlighting the need for transparent AI in complex systems. Then Microsoft Tay chatbot. Microsoft Tay chatbot in 2016, the issue is they produced offensive content after interacting with the users. So the explainability means in the system has showed that the risk for deploying AI without clear understanding of its learning process. That means they produce offensive content after interacting with the user. That means he used some data by interacting with the users. So that the risk in that factor is deploying AI without clear understanding of the learning process. The next one is the privacy and the data protection in responsible AI. So the privacy and data protection involves safeguarding the personal data. So in this system, sometimes the personal data may be used. So safeguard this personal data and ensuring system that handles sensitive information securely and ethically. So all the data that is sensible data should be handled very carefully and protect that data in a correct way. So data key points are data minimization means collect only the data necessary for the AI purpose. That means when you in the case of building an AI system, collect only the data that is necessary for the AI system. Means we avoid the unwanted data instead of collecting everything for that system. We identify what all data is necessary for building a system and collect only that necessary data only. Then anonymization and encryption protect data by removing identifiers and encrypting sensitive information. So the protector protect the sensitive data in such a way that some from encrypting methods can be used for any encrypting methods can be used for encrypting the data. Also remove the identifiers. Then encryption means, you know what is encryption? We protect the data by encode it in some other way, and it is decrypted only after it is needed. So that some person, when it receives that data, he cannot identify actually what it is. So user content ensure that users are informed and consent to the data collection and usage. So what all users can be used that data, because it is a sensitive data, and that should be handled with carefully, with protection and privacy. So what all users can be used for, what all users can use that data, and also to take consent while using that data without encryption. So benefits of that system is trust and compliance. That means build trust with the users and ensures compliance with the privacy regulations like GDPR. Then risk mitigation is reduces the risk of data breaches and misuse. So after privacy and protection, the data is very much protected, so that any breaches of misuse of data should not be occurred. So the privacy and data protection, that some real life cases are Zoom data sharing in 2020. Zoom, we are using the Zoom. So Zoom was found to be using user data with third parties. Actually, Zoom medias are usually mainly used while at the time of COVID cases. This main video conferencing tools are mainly that exponential uses came at the time of the COVID cases. So at that time, Zoom was found to be sharing user data with the third parties without dedicated disclosure. So this result in the privacy and protection of the data. That means personal data is Zoom data is mainly the personal data. Many users are using this Zoom platform. So the details of so many users are there. That means user profiles are there with the Zoom, that find to be shared with the third party. So that result in the privacy backlash and new security measures to be protect user data. So that is one incident in the privacy and data protection in 2020. Then Google Street View data collection. Google Street View data collection means Google collected sensitive data, example Wi-Fi data, without consent during the Street View mapping. So sometimes that lead to fines and stricter oversight on data collection practices. That means it is the data is sensitive data, so it cannot be shared with any other person or the third party, because it contains personal data and also the sensitive data. That are the two real life cases of the privacy and the data protection. So next is environmental impact of AI. You know, from this graph, you can see that the environmental impact of the air travel, human life, then American life, and US car, then training an AI model. So for training an AI model, the CO2 emission is very large compared to a US car. Okay, compared to US car, it is very, very large. So training an AI model, it requires a huge amount of data to be trained. It requires large system. So the computation process that require more computational large systems to compute that training process. So that CO2 emission is very large in the case of this training a data. So the second graph, you can see the emission notable in the AI system. So the major AI systems are here: OpenAI, Google, Meta AI, Alibaba, Infection AI. Then there are 20 AI systems in terms of carbon emission for a single training run. This graph is for a carbon emission for a single training run. So you can see how much CO2 emission for a simple run of a training run. So while building an AI system, you know that it is not possible to develop an AI system by a single run. So it takes number of efforts to develop a good AI model. So what that much CO2 emissions are there while developing an AI system. So exponential growth in the intensity and scale of AI computing that demands urgent regulatory action to mandate green AI and ensure sustainability. So while building this AI systems, we should ensure that it should be a green AI and it should ensure the sustainability of the system. So the green dilemma is AI's carbon footprint and electronic waste disposal. So AI carbon footprint, we have already seen that how much carbon emissions in the case of while building an AI system. That means in the simple run of a training. So carbon footprint, the common carbon footprint benchmark are also here in IBS of CO2 equivalent, sorry, LBS of CO2 equivalent. So the transformer neural architecture search, it is this much amount. So in the case of USCAR, it is only 1,26,000, but in the case of transformer neural architecture search, it is 6,26,155. Transformer means we are building an LLM models. Okay, transformers are mainly used for building an LLM models. So the impact of natural ecosystem means resource extraction, the mining of rare earth metals, essential AI hardware can have detrimental effect of the ecosystem and the community. Resource extraction means the what all resources are used for building, used for that system. That means what all earth metals are required for building the AI hardware. So, you know, while running in, so for running an AI model, to develop an AI model, we have to build a system. That system should be contains more hardware than a normal system. So we should ensure that the earth metals are used very in very low scale while developing a hardware for AI system. That means a system that can run on AI models. Then data collection, gathering vast amount of data for AI training can involve activities like satellite imagery and drone surveillance, potentially impacting wildlife and habitats. So, for example, suppose we have built an AI model that use more images for the geographical data, like that. In that case, we collect that data by satellite imagery or drone surveillance. Images are taken by using a drone. So it potentially impacting the wildlife and the habitats also. So what are the benefits of this responsible AI? So minimizing the bias in the AI model, that is the most important thing in responsible AI. Minimize the bias. Then we know how to minimize this bias. We discussed here what all bias occurs in the case of responsible AI also. Then how to minimize this bias, then enhance the transparency and trust. The system should be built, that system should be transparent and it is trustworthy. Then creating opportunities, then prioritizing the data privacy and the security. So the AI system, the data used in the AI system should be secure, and all the data should be encrypted in such a that no one can attack that data. Then effective risk management. So these are the benefits of responsible AI. So the best practices are data quality and validation. Okay, data quality and validation means, as we discussed earlier, we collect data in such a way that should contain all the demographics, historical data, and all what all things to be included in the data, collect data in that way. So quality of data should be increased by collecting all the types of the data. And validation means we should validate the system with different types of data. Okay, the system should be work perfectly if the input when it is validated with the set of input, that means the inputs you get. Then model interpretability. Then the AI model should be interpretable, and it should be built in such a way that it is an accurate system, so that it will generate correct output. And it is there is no social discrimination in that system. Then data integrity. Data integrity means it includes data integration, data quality, then location intelligence, and data enrichment. So that is constituted, that all should be in the data integrity, and the data should be accurate, consistent, and contextual data. Then continuous monitoring and evaluation. That means first you should regular assessment of the AI system. Then identify and address the emerging ethical challenges. What are the ethical challenges occurred in the system? Then ensure alignment with the ethical guidelines. So these are the continuous monitoring and evaluation. So a good AI system can be built by continuous monitoring of all these things. Regular assessment means we regularly assess what all things to be done by this AI systems. Then identify what all ethical or biases occurred in this system. Then what all challenges are there, identify that one, and ensure that the system align with this ethical standards. Then explainable AI means it is explainable to justify, explainable to control, explainable to discover, and explainable to improve. And the role of human oversight is ensuring the reliability, detecting contextual nonsense, bias mitigation, handling edge cases, assessing unforeseen variables, quality assurance, accountable and ethical considerations. That means human should oversight in ensuring reliability. He should detecting all these what all novel things are included in this included by building the system, so that novel values are important, and it is aligned to that context. Then bias mitigation process are to be done to mitigate the bias. Then all cases are handled. Then assessing the unforeseen variables, what all variables are or what all attributes are there in the system. Then unforeseen means sometimes that attributes may be not validated or not countable. Then assess that attributes. Then quality of the system, ensure the system should be very much, the system should produce quality outputs. Then accountability and the ethical considerations. That means it should follow the ethical standards. That is the role of human oversight in ensuring the reliability. So these are the best practices to develop a AI system without any bias. So that's all about this understanding and mitigating bias in AI models. Hope that all of you get a very good idea about what is bias, what all what all bias are to be occurred in a system, what are the different types of bias, and how to mitigate the bias, and what is responsible AI, and what are the principles of this responsible AI. Okay, that all we discussed here. Thank you so much. Now you can ask any queries, or if you have any doubts, please feel free to ask.
It was a very informative session, ma'am. Thank you. Now the
Thank
participants
you.
can ask their doubts.
If you have any doubt regarding this, please ask.
I think there is no more doubts.
Mm. Okay, it's
Okay.
okay.
Uh, Now I welcome Miss Aishat Sufaina K, Department of Media and Communication, Assistant Professor, Majlis Arts and Science College, Paramanur, for the rapporteur duty. Aisha ma'am.
Hello, is this audible?
Yes, ma'am.
Thank you, Chitra ma'am, for this opportunity. So, as she earlier said, that it's a very important and very informative session. So, good evening, everyone. Here we summarizes in the session understanding and mitigating bias in AI models by Dr. Sheena ma'am. She explained that although AI aims to reduce human error, we all know that it often picks up the same biases that exist in the society. A bias happens when system produce unfair or inaccurate results because of the skewed data or design choices. We looked at different types of biases like sampling bias, algorithmic bias, measurement bias, stereotyping, automation, etc. And all that appear in the real world systems like hiring tools, criminal justice algorithms, and generative AI. The session also discussed how bias can reduce through better data collection, fairness focused model design, and careful monitoring of AI outputs. Dr. Sheena ma'am also highlighted the environmental cost of large AI models and the importance of sustainable green AI. So we looked at the biases that AI it can happens during data collection. This mean bias is not caused by one single factor, but appears throughout the entire development process. The session also focused on mitigation strategies. These include using more representative data sets, adding fairness constraints while training models, auditing AI outputs regularly, and ensuring a human in the loop approach. For generative AI, the importance of diverse training data and safety filters was emphasized. And also, the speaker touched up the environmental impact of AI, noting that training large models requires significant energy. This highlighted the growing need for sustainable and green AI practice. And overall, the session emphasized that AI bias is both technical and ethical concern. Ensuring fairness requires careful data practices, transparent model design, and continuous monitoring. So, really, it's an important and very informative session for all of us. We are getting more information about how the biases of AI and what are the sustainable goals we need to practice. So, thank you, Shina ma'am. Thank you so much.
Thank you, sir.
Now I invite Ms. Jinsi PB, Assistant Professor, Computer Science Department, to deliver vote of thanks. Jinsi ma'am, please.
Hello, good evening. Am I audible?
Yes, ma'am.
Okay. On the behalf of everyone gathered here, I would like to express my sincere gratitude for making this first session of the day truly meaningful. First and foremost, my heartfelt thanks to our principal, Mohammaduti sir of Majlis Arts and Science College for his continuous support and motivation which make programs like this possible. I extend my deep appreciation to our resource person of the session, Dr. Sheena N., Assistant Professor, Department of Computer Science and Engineering, CEM, Punnapura, for delivering such an engaging and insightful session. Your clarity and expertise have enriched our understanding of the topic. Thank you, ma'am. A special word of thanks to Ms. Ashiat Sufiana for the warm welcome and for setting the perfect tone for the session. Thank you, ma'am. We are also grateful to our IQC coordinator, Rafiq sir, and our AICT coordinator, Chitira ma'am, for their valuable guidance and involvement throughout this program. Thank you all. Our sincere appreciation to Mr. Agil for providing smooth and prompt technical support. Thank you, sir. Thank you all once again for your presence, cooperation, and contribution in making this session a success. Thank you.